So completing the square. We utilize completing the square when we're working with quadratics because it's one of the methods to solve an equation. I don't know if you guys have ever completed the square before. It's one of those things that you may or may not have been taught in Algebra 1. It really kind of depends on how much time you guys had. But it's one of the methods to do that is, oh, let's worry about this, is to do this. We have a quadratic, x squared plus 10x minus 3. And I want to solve this equation, solve for my zeros, because I can't factor it. Because obviously, what times what's negative 3, you add together to get positive 10. There's none. But I can still solve for my zeros here by using what's called completing the square. What I'm going to do is I'm going to create this. I'm going to create a junk squared piece on one side, and it's going to equal something on the other. Because when you have a junk squared, then you can take the square root of both sides to help solve it through. Yeah, Emma?
Are we turning in this?
No. Okay. So it actually is I know that you guys like to be told a specific way to do a problem because you can replicate it and do the same thing over and over again. Then you're gonna like this because it's the same thing over and over again. It's just a matter of remembering how to set it up, okay? So what we do here is we're gonna set up a way that we wanna get this junk squared term. Now remember, if it's a junk squared term, you get something, if it's a plus b quantity squared. If you FOILed that whole thing out, you'd get a squared plus 2ab plus b squared. You guys remember that? Now, what we want to do is we need to break apart this, bless you, this middle term to be able to figure out what that part's going to be for the squared end. And it's a very simple process. Here's what we do. We're going to take this, the first thing you always do is you move c. What's c in this case? How do you move it? Add it. So we're going to write x squared plus 10x plus blank equals 3. I always put a blank in there. That way I'm forcing myself to remember that something needs to go there. So here's what we do then. Now we take half of b. What's our b value? 10. What's half of 10?
5.
5. Oops. Was that 5 positive or negative?
Positive.
Positive. So you write it here. And now you square it. What's 5 squared? And you write it here. And you write it here. And that's how you do it. You take half of b, you square it, and you add it to both sides. Because if I put 25 on one side, to keep it balanced, I gotta put 25 on the other. By taking this half of b term, half of 10 is 5, 5 squared is 25, I can create junk squared. And that's how that works. So then I get the term x plus 5 quantity squared equals 28, which means, what do I do now to solve it? Yes, sir?
Why do you divide by 2?
Remember when if you FOIL something out, if I FOIL out x plus 5, x plus 5.
Because you know that you're going to be adding 5x and 5x?
Correct.
Yeah,
Because knowing that this middle term is the same term added together, it's twice, I'm cutting it apart to figure out what each one of them was.
So couldn't you do like 8 and 2? Like it still adds up to 10, but
But what I'm trying to do is create this perfect square. I'm trying to create this junk. I want it to be the exact same term because when I get to this part here, all I have to do is take the square root of both sides and I can solve it. That's what I'm trying. You're right, it could be 8 and 2, 8 and 2 to add together, but I'm trying to figure out a junk squared term. Does that clear that out? Yes, sir.
Where did 28 come from?
What's that?
Where did 28 come
3 plus 25.
from?
And then you get x plus 5 is plus or minus 28, I think, simplifies out to be 2 root 7. And you get x equals negative 5 plus or minus 2 root 7. It's some crummy decimal. It's factorable. It just gives you a crummy number. And those would be your answers. That would be your answer. What are the zeros? There you go. Okay. So, like I said, the process by which we do these things is actually pretty simple, because at the end, you get to do this. Yeah, Julie?
What even is completing a square? Like, why do you need to do it?
Okay. What you're trying to do is you're trying to take a, let's see if I can do this. You're trying to take a piece of paper. A piece of paper is rectangular, right? Now, if I make it so that it's square, paper's what, 8.5 by 11, I believe?
Yeah.
So if I make it where it's going to be 8.5 by 8.5, if I do this right, this should work. Now I'm square, right? The only reason why I'm square is because I've taken this piece out. Now, if I take this, this is my b value. Oh, you remember doing this before now, right? The minute, oh.
I just get it. I just get it.
So if I take half of b, and I can do this without destroying it. Yeah, I should do that. No, oh well. If you squint, it's nicely cut straight. I've taken half of b, and I've built it on both parts. So if this is half of b, and that's half of b, this last little spot up here is a square, isn't it? How do I find that part? Well, it's half of b times half of b. So it's that part squared. And I've completed a square then. In a roundabout kind of way, that's what you're doing. You're taking a sheet of paper, a rectangular sheet of paper,
Perfect.
and you're trying to turn it into a square.
So to like reach side and perfect
Yeah.
matching dimension.
Yeah, you're trying to move it around so that way it becomes something that you can solve. Because in theory, we should be able to solve those problems. Okay? And it works whether it's an imaginary solution or not. We can get all these things. Okay? Let's try another one.
That was
Same deal. X squared minus 16x plus 76. And we're going to try and complete the square again. Excuse me. Each and every time you want to complete the square, your first step is to always move the value of c. Always. Do that first. So if I'm looking at this, I have x squared minus 16x plus 76 is 0. How do I move the 76? Subtract. So then I get x squared minus 16x plus blank is negative 76. You okay with that? Now, I take and I find out what half of b is. Notice, I brought it as negative 16 because what's my b value? It's negative 16. Convenient. What's half of negative 16? Negative 8. So this is negative 8, which means in my parentheses it's going to be x minus 8. If I square negative 8, what do you get?
64.
Positive 64, which means I add 64 to this side, and I add 64 to that side. So now what's negative 76 plus?
-12.
Negative 12, very good. Hey, on the quiz, you had one that had the square root of negative 12. 2i root 3. Very good. Good morning.
Good morning.
How are you?
Good, how are you?
I'm fantastic. Thanks. Actually, got a little. I'm coming down with something. That's all right.
Can I talk to Katie Stern to the bird one?
Whatever. Yes, sir.
Why would you add?
Why do I add 64? Because, again, what I'm trying to do here is I'm trying to make this what we call a perfect square. Because this is junk times junk.
If you subtract 64 from that side, you no longer have that.
Ah, but if I keep an equation balanced, if I add the same thing to both sides, does it say balanced? Because this is this, foiled out. We're trying to take some quadratic to create a quadratic that turns into this. Because when I go to solve this problem, all I have to do is take the square root of both sides.
Yeah, but wouldn't that equal negative 76?
What? This?
X minus 8 squared, wouldn't that equal negative 76?
No, it equals the negative 12.
Why then?
Why? Because I took since I take an equation that you keep things balanced by adding the same thing to both sides. So negative 76 and 64 gives me negative 12. Whenever you move stuff to other sides, you have to do it. Whatever you do to one side. Remember, numbers are jumps. Whatever. It's like if your sister got something, you'd want something too, wouldn't you? Exactly. So if she gets a new car, you're gonna say, Mom, what's the deal? I want a new car. Am I right? So it stays balanced. It's a bad example, but it works. That's all it is. You have to add something the same. You have to keep it down on both sides. All right. So then you get x minus 8 is plus or minus 2i root 3. It is not 3i root 2. And your final answer is x equals 8. So what you're able to do by completing the square is we're able to factor quadratics that have imaginary roots. Yes, ma'am.
If you already have the plus or minus, is it necessary to have the I?
Yes.
That contradicts.
No, you have to because when we took the square root of 12, a negative 12, the answer
Oh,
is
the plus
2i.
or minus is just because of the 8?
The plus or minus is because we took the square root on both sides of the equal sign.
Oh, okay.
Anytime you take a square root on both sides of an equal sign, you have to put the plus minus. Okay. That's all. Let's try another one. X squared plus 4x plus 1 is 0. Now, I don't know about you, but I'm not quite sure how to, what times what is 1 that you add together to get 4. A whole lot of nothing. So I'm going to set this up to complete the square. Also notice a lot of times when we completed the square, our our b value was always what? It's even. It's a lot nicer when it's even, isn't it? So what's your first step?
Minus
Move
1.
C. Minus the 1. Good. So I have x squared plus 4x plus blank is negative 1. Now, what's half of 4? 2. You can come in. Sweet. So we take half of b. It's 2. Is it a positive or a negative 2?
Positive.
So what goes into my term?
X plus 2 squared
I square it, and what's 2 squared?
equals 3.
Square, you get plus or minus 3
Very good. And now you can finish the problem out by taking the square root over both sides. And that's usually the easiest way to solve equations.
X equals negative 2 plus or minus square root 2. Oh, 3. What the? Where did I go?
Yes. 4 minus 1. Okay.
No, I did it. I just randomly wrote 2.
Just messing with you.
Oh.
You know what? Let's do another one of these before we get into that. Go for it. Take a minute and solve it.